Hi, everyone. My name is Ellie. I'm a second-year PhD student in Chemical Engineering Department in the University of Utah. And I'm so honored to have the opportunity to talk about my study on combined heat and power systems. And the main question for our study is, should combined heat and power systems be part of energy efficiency recommendations in a constrained airshed? We all know that the Utah's Wasatch Front and Uintah Basin do not meet the national ambient air quality standards. And one of the greatest contributors to air emissions is energy sector. And energy efficiency measures can lower emissions by reducing the need of for electricity generation and by directly reducing combustion emissions. And one of those energy efficiency measures is combined heat and power systems, or CHP. But what is CHP? CHP systems actually generates electricity and uses the wasted heat in electricity generation for process heating, for providing hot water for a facility. It has higher overall efficiency, about 75% in comparison to a conventional method when we have an on-site boiler and purchasing electricity from grid. But CHP results in an increase in natural gas usage on site, while we have a decrease in electricity consumption. For a case study of our evaluation, we selected the Intermountain Industrial Assessment Center, hosted by the University of Utah, to kind of evaluate the CHP systems. In 2019, IIAC group performed 19 assessments and provided 100 recommendations. In general, they had electricity savings and natural gas savings, about 93 gigawatt hours electricity savings and 100,000 million BTU natural gas savings. But among those recommendations, they had 2 CHP implementation recommendations. And our main question is that how do these 2 recommendations, 2 CHP recommendations, affect the air quality in a constrained airshed like the Wasatch Front? So the goal of our study is, first, we want to analyze how CHP systems affect emissions, and we want to determine the associated health effects. And we also want to consider emission control systems on CHP. And the last question would be, does it make sense to install a CHP system in a constrained airshed? For the methods, in the first step, we collected all the energy efficiency recommendations made by IIAC in 2019. And we assumed that all of those recommendations were implemented. Then we looked at different emissions estimation tools like avoided emission generation tool, and EPA's AP42 documents to have the emission rates for electricity and natural gas. Then we considered 2 different emission control systems, lean premix combustion system and also the selective catalytic reduction system. And the last step, when we had all those emission changes, we used the EPA's co-benefit risk assessment tool, or COBRA, to translate all those emission changes into health outcomes. So here is a list of our different scenarios that we used. These 8 scenarios, we had 2 different electricity emissions estimations. We used eGrid and AVERT. We considered natural gas emissions as well, because in previous studies, they just focused on the electricity, not the natural gas. We had the uncontrolled CHP system when we have no emission control system. We considered lean premix combustion, SCR system, and the no CHP recommendations are, the no CHP scenarios are, what if we had no CHP in 2019? And we did that these 8 scenarios and got the results for just Utah State and the entire US. So let's look at the electricity and natural gas savings from 2019 IAC recommendations. If you look at the 2 first columns, those are the electricity savings with and without CHP. And as you can see, we have more electricity savings with CHP systems. But if you look at the natural gas usage, since we increase the natural gas usage on site, we cannot have that much natural gas savings. So we have less natural gas savings with CHP recommendations. Then we looked at 5 different emissions and the change in those emissions with IIAC recommendations. So as you can see, the first 2 columns is emissions associated with electricity with and without CHP recommendations. And as we expected, we have more emission savings with CHP systems. But we know that since we increase the natural gas usage, we have an increase in NOx emissions with CHP recommendation. And that's the problems that we're going to focus. If we use different control systems like the lean premix, we can actually reduce that adverse we can actually reduce that tons of NOx emissions, because with the uncontrolled system, we increase the NOx by 22 tons per year. But if we implement lean premix combustion system, we can reduce that to the 2.73. If we implement the selective catalytic reduction system on our CHP, we can actually decrease the NOx by 5.5 tons per year. Then we translate all those emission changes to the health outcome using COBRA, one of EPA's tool. If you look at the picture on the left, you can see the results for the entire US. As we expected, we have a highest health benefits with selective catalytic reduction system. But in general, these are the results for all the recommendations in 2019, not just the 2 CHP recommendations. But the thing is that if you look at just Utah State, we can see that we have a negative health outcomes with CHP recommendations if we implement no emission control systems on that one. So in general, we can say that CHP system has some benefits and some drawbacks, but the benefits would be with CHP systems, we have an increase in overall efficiency. We will reduce the electricity consumption from grid, so consequently we reduce the emissions related to electricity. And the energy resiliency is one of other benefits that we can have with CHP systems. But we have to notice that we increase on-site natural gas usage with CHP systems, which results in an increase in on-site emissions. And we might have an adverse health outcomes with in a region with populated area in comparison to an unpopulated region. So to conclude, we can say that CHP needs careful consideration when we want to recommend that in a constrained airshed, and different control systems on CHP can reduce that adverse health outcome in a local region. And the SCR provides the highest NOx reduction. So this is the best option that we can have when we want to implement CHP systems. But 2 main factors that we want to notice is the site location and also emission control systems when we want to recommend that in a constrained airshed. Finally, I want to thank Dr. Carrie Kelly, my advisor, and also Dr. Cody Powell, the IIAC director, and Intermountain Industrial Assessment Center for providing the required data. Thank you for your attention, and I'm happy to answer any questions.
Okay, who wants the big foam thing here? Any questions? I've got one then.
Sure.
On the local stage, just look at Utah only, you had health disbenefits, if you will. What was the cause of that?
So the main cause is that when you implement CHP systems, so those two recommendations were about the implementing CHP in a Salt Lake City. So when you implement CHP, you actually increase the natural gas usage because you have to provide the fuel for the turbine. And that increase in natural gas usage on site results in a higher emissions on site, and you can have the negative health outcome for a local people.
Just very localized emissions then? There's a question. I won't throw this too far.
Hi, you talked about the IIAC Center doing assessments, and these are where their CHP recommendations came from. But what other sort of things is the IIAC looking at and looking for and recommending?
Yeah, that's a good question. So I'm a member of IIAC. So in IIAC, we looked at small and medium-sized facilities. We go to an on-site visit, and we recommend them to look at their highest energy consumption equipments like boilers, compressors, and then we recommend them to implement some energy efficiency measures. Like, for example, we say, okay, you have to check the air compressor leaks, if we want to talk about the leaks. Or if you're looking at the boilers, we said, okay, you have to tune your boiler. We do measures with the stack of a boiler, and we use flue gas analyzer, and we recommend them, okay, you have to tune your boiler, or you can use a heat recovery of your boiler. So some of these recommendations that we made, and we recommend them to implement those recommendations and save money by saving natural gas or electricity.
Okay, I think I'm going to cut it off there. If you have further questions, please ask Ellie